If you have RNA-seq data for the same samples as your RT-PCR data, you can easily compare them, for example, to confirm that the RNA-seq data looks similar to earlier RT-PCR validation. You can add your data directly to your RT-PCR project or import them to a new project. In this tutorial, we will be using FPKM data already in a tab-delimited file. The file only has data columns and header rows and columns to identify the genes and samples, so we will not select any descriptive columns. We will add design and annotation tables. In order to match up the samples and variables, it is essential that the names match. For variable names, a carefully controlled gene ID, such as ensemble IDs, work well. For sample names, you can include metadata columns to your design table to match between RT-PCR and RNA-seq. You will want your data to be properly normalized and transformed. We like to use upper quartile normalization and log2 transformation with a small pseudo count. These data have already been normalized but not transformed, so let's do that. Choose microarray, pre-process, transform. Choose the correct project and your data. We imported our FPKM data as microarray expression data, so don't worry about this title. You can choose to add custom constants and your transformation, or use a pre-configured transformation method. If you don't give an output name, your input data will be overwritten. You can easily move objects between projects. Right-click, copy object, and paste object. You can now close the other project. Now we can run microarray integration. Again, neither of these projects actually have microarray data, but microarray just refers to any L-shaped data where you have measurement data with associated design and annotation data, frequently called omic data. Choose the RNA-seq data as our first microarray data object, and the RT-PCR data as your second microarray object. Name the output, and the labels of the axes. Now match the variable and observation columns. Our RNA-seq design table contains a column called Match to RT-PCR, which should match the observation ID for the RT-PCR. We can change the colors, such as by tissue, and add a regression line. Let's change the title. For each gene that was matched between the RT-PCR and RNA-seq data, you will find a separate chart, and you will find a data point for every sample that was appropriately matched based on the specified columns.